standard conversion factors, such as kilograms to grams, inches to centimeters, things like that. Things that never change because those are definitions of those measurements. However, we're going to be looking at non-standard conversion factors today, which are things that can change based on what you're talking about. Can anyone maybe think of an example of this? A conversion factor that might change based on what you're talking about. What about your car? Can anyone think of a conversion factor that would apply to your car? Yeah, miles per gallon. That's a conversion factor that depends on which car you're driving. Some cars are 19 miles per gallon, some cars are more, some cars are less, right? So miles per gallon, that's conversion factor, and it changes depending on the car. Also speed, so miles per hour or kilometers per hour if you're in Canada, things like that. Also another one is density, grams per milliliter or mass over volume. Sometimes it's in grams per mil, sometimes it's in other units, and we'll talk about that. Density depends on what you are talking about. A rock is more dense than water. These are all things that we will be using today. Because they are non-standard, they always affect sig figs. So non-standard conversion factors always affect sig figs. Because when I give you a conversion factor, I'm saying, you know, if it's 19 miles per gallon, I'm saying it's approximately 19 miles per gallon. I don't know if it's 19 miles to the inch per gallon or to the, you know, I give you a certain number of significant figures there, and you have to base your significant figures on those. So a car has a mileage of 24 miles per gallon. How many miles can be traveled? Oops, forgot the E there. On 6.41 gallons. Now this is a conversion factor that this is a problem that you've probably done before. In a math class or a science class, but I really want to make sure that we do this in the same way we've been doing all of our unit conversions, because we will make these conversions longer. So I'm going to start when you're given an amount, that's what you want to start with. You don't want to start with the conversion factor. What's the conversion factor I give you? What's the conversion factor I give you in this problem? 24 miles per gallon. So what's the amount I give you? 6.41. That's something that can be measured, okay? That's a physical amount. You're going to start with the physical amount, 6.41 gallons. And then in this case, you're going to put gallons on the bottom because you want to get rid of gallons to go to miles. So 1 gallon is 24 miles. Remember what I said about non-standard conversion factors always affecting sig figs. So in this case, how many sig figs should my answer have? 2. I heard someone say 2. And that's correct because 6.41 has 3 sig figs. The 24 miles per gallon has 2 sig figs. This is the placeholder one. So that doesn't affect, but the 24 does. And so you're saying basically, you can treat this as an equal sign saying 24 miles equals 1 gallon. And you're going to base it on that 2 sig figs. So your answer would normally be 154 miles. But with the proper sig figs, it will be what? 150. So that's your answer. Any questions on that? So 150 with no decimal because we don't want that last 0 to be significant. Well, good so far? Sometimes you will have to flip these conversion factors. And when you're doing that, you can say, for example, if I say, for the same car, how many gallons are needed to go 260 miles? In this case, you're going to start with the amount that's measured, that miles. That's your amount, 260. And then you're going to use your conversion factor. However, in this case, you're going to put the 24 miles on the bottom. Okay? So you have to flip that conversion factor completely, not just the units, but the numbers, right? Because once again, that line that's saying 1 gallon equals 24 miles. So 24 miles is going to go on the bottom. And 1 gallon is going to go on the top. You have 2 sig figs here, you have 2 sig figs here, so your answer is going to have 2 sig figs. In this case, that conversion factor didn't change your answer because the amount you started with also has 2 sig figs. And your answer is 10.8 gallons, but what do you need to round that to? 11. So round it up to 11 to have 2 sig figs. I saw some people forgetting their units on the worksheet on Monday. On your test, if you don't put your units, if there's units, for an example, like a question like this, if it's just like 10 plus 15 divided by 45, something like that, it doesn't have units. But a question like this does have units. So you need to know what it is, because you could be talking about 11 children, you could be talking about 11 inches, but you're talking about 11 gallons, and I need to know that. So you get a point off if you don't write your units, so always do that. I'm going to have you practice with one that's about density. So same kind of thing where you use your non-standard conversion factor. And I would say, so let's say salt water is 1.012 grams per mil. How many milliliters weigh 16.8 grams? So just getting used to using these non-standard conversion factors. Go ahead and do this problem. It's just a one-step problem. Also, make sure you bring your calculators on Friday. You will need them for the quiz. I will not have an extra one for you. You should bring your calculator every day, but especially on quiz and test days. And you can't get extra time if you come in late for that quiz. So be on time. What do we start with? 16.8 grams. What goes on the bottom? 1.012 grams per 1 mil goes on the top, and your answer should be 16.6 mils. In this case, yes, this non-standard conversion factor would affect, but it has 4 sig figs. The number we started with has 3. Questions thus far? These are just relatively simple one-step problems. I just want to make sure that we get it really clear that we can flip these conversion factors before we move on to the next thing, which is combining standard and non-standard conversion factors. Does everybody have this down? Can I switch to the next? Okay. A car with a mileage of 19 miles per gallon travels 1.01 times 10 to the 4th meters. How many liters of gas does it use? And I will give you a couple of standard conversion factors. 1 mile, 1 kilometer equals 0.6 is about 0.621 miles. And 1 gallon is approximately 3.785 liters. This is a really good candidate for writing a unit map. If you look at a question and your first thought is, I don't know how I'm going to get from that to that, start with a unit map. Instead of just throwing down numbers, start with a unit map. It will help you move through the problem more quickly, give you more time, and help you be more accurate in your answers. Now, the conversion factor, we're going to use the mileage because the mileage is what's getting us from the distance unit of meters to the volume unit, miles per gallon. So you're going to have to go through that to get from distance to volume. However, we're in meters, we want to be in miles. So you always have to convert to the units of that conversion factor. Meaning, I'm going to start with meters. Where should I go next? Kilometers, because then we can get to miles using this conversion factor. So I'm going to go from meters to kilometers to miles. Then where am I going? Gallons, because we can use our miles per gallon, our mileage, gas mileage. And then I go to liters, because that's what I want at the end. Highly recommend writing out your unit map. Okay, I'm just going to write out my units. I'm going to write out the first thing and then lay out the units. So I'm going to start with 1.01 times 10 to the 4th meters. Meters are going to be on the bottom, kilometers on the top, kilometers on the bottom, miles on the top, right? Because every time we move from one unit to another, we want to cross out the previous unit. Then we have to get rid of miles and go to gallons, and finally gallons to liters. Always write miles as MI and meters as M. They are 2 different things. Write them as 2 different things. Don't write miles as M. That is wrong. You will get that wrong if you put it in your answer as M when your answer is supposed to be in miles. Now let's put in our numbers. What's the conversion factor from kilometers to meters? 1,000 meters in 1 kilometer. So a meter is about this big. A kilometer, you actually, like, it would take you a while to run a kilometer, a few minutes at least. So there's a lot of the small thing and the big thing. That means it's 1,000 on the bottom to 1 kilometer, or 10 to the third. That's what you need. You need to know that for the quiz. You need to know how to do that for the quiz. Now we know that 1 kilometer is 0.621 miles. And we know that 1 gallon is 3.785. Oh, no, sorry. I skipped. I need to use the gas mileage there. Not quite there. So the gas mileage is 19 miles per 1 gallon. Then we use 1 gallon is 3.785 liters. Can anyone tell me how many significant figures we should have? Hearing a lot of 3s, that's incorrect. It's 2. So, does this affect your sig figs? Yes, because it's a number I gave you. Does this affect your sig figs? No, because it is. Oops, don't want to touch that. Because it is meters to kilometers. That's metric to metric. That's exact. It does not affect your sig figs. Does this affect your sig figs? Yes, because it's an inexact conversion, because it's English to metric. Does this affect your sig figs? Yes, because it's a non-standard conversion factor. Does this affect your sig figs? Yes, because it's metric to English. Okay, so the only one that doesn't affect is metric to metric, because that's exact. The metric system was designed for 1 kilometer is exactly 10 to the 3 meters. So you can imagine, I mean, a lot, you can imagine just infinite sig figs on those. However, English to metric, it's like converting between 2 different languages, translating between 2 different languages. So it's not always going to be an exact translation. So those significant figures affect your answer. Meaning 4, 2, 3, and 3 sig figs. How many sig figs should our answer have? 2. So your answer is 1.249 liters, which will be rounded to 1.2 liters. Any questions on that? Yeah.
Just like
no, you only round based on the next digit.
Okay.
Because think about it this way: if you can always round it from the next digit, you could like do infinite rounding, right? So you always base on the next digit. Okay. Multidimensional analysis. So sometimes volumes and areas are expressed as a unit cubed or a unit squared. For example, an area, right, is a unit squared. So you could have feet squared in an apartment. You can have miles squared. But there are also units that for area that aren't in squared units. They take into account the fact that it's already an area, and that's things like acres, right? So an acre is already an area unit, whereas miles squared is a distance squared unit, it can express the same value, but it just looks different in terms of the units. A really common one that you guys will have to know for the test is 1 centimeter cubed equals 1 milliliter. That's an equivalency. That's saying, so milliliters is the volume unit, but that's the same as saying centimeters cubed, which is just a distance squared unit. So a mil is let's see. So if you imagine the top of this pen was filled with water, it would be about that much water from the top of my nail up. That's equal to also saying, okay, it's 1 centimeter by 1 centimeter by 1 centimeter. And when we convert between squared units to squared units or cubed units to cubed units, we need to take into account that squaring and that cubing in the math. And I will go through what I'm talking about in that case. I could say convert 210 meters squared to kilometers squared. Do you know the conversion from meters squared to kilometers squared? No, you don't. You know meters to kilometers, but you don't know meters squared to kilometers squared. Lose your knowledge of meters to kilometers by doing it this way. So I'm going to put 210 meters squared. I'm going to start with that. So what goes on the bottom? Next up, meters squared. And what goes on the top? Kilometers squared. We're trying to get into kilometers. When both units are squared, you can pull that square out of the parentheses and then write in your conversion factor, and that just means that we will square the conversion factor. So we're going to put 1 kilometer over 1,000 meters. Now this means that what you're going to put into your calculator is 210 divided by 1,000 to the 2. Can everyone put that into their calculator and see what they get? You should have gotten 2.1 times 10 to the minus 4th, or 0.00021. Did anyone not get that? Does anybody have a question as to how to put that into their calculator? Can anyone tell me why we didn't square this number here? Yeah, so the unit is already in meters squared. It's already in an area unit. The only thing we need to square is the meters to kilometers, because you're using a one-dimensional conversion factor in a two-dimensional system. Okay, so let's talk about this in terms of a volume. If I have 1 meter squared, so it's like 1 meter by 1 meter by 1 meter. Okay, so it's like this amount. When I'm going from centimeters to meters, if I'm trying to figure out how many so that's meters, meters cubed, that's 1 meter cubed. If I'm trying to figure out how many centimeters cubed are in that, I have to account for the fact that this is 100 centimeters times this is 100 centimeters times this is 100 centimeters. So that means it's 100 times 100 times 100. So when you convert from meters cubed, you have to cube that 1 to 100 conversion factor. Does everyone understand that? We'll get a little more practice. So when we convert, let's say, so 6, let's see, hold on one second. Convert 6 meters cubed to centimeters cubed. I'm going to start with 6 meters cubed. What goes on the bottom? Meters cubed. You have to get rid of that exponent too. So meters cubed goes on the bottom. And then what goes on the top? Centimeters cubed. And now what can you do with that cube? Pull it outside of the parentheses. Now, what's your conversion factor, centimeters to meters? 100 to 1. 100 cents in a dollar, 100 centimeters in a meter. When you put this into your calculator, you're going to put 6 times 100 to the third. Can anyone tell me what they get for that answer?
6 million.
6 million. 6 times 10 to the 6. Oh, I forgot to put my units there. So we've gotten rid of, so this cube refers to both the units and the number, the unit and the value. This value, 1 cubed is always going to be 1, 1 squared is always going to be 1. So that you don't necessarily have to put into your calculator. But, so we've gotten rid of meters cubed, and we're left with centimeters cubed. 6 times 10 to the 6th centimeters cubed. We can volumetric units like liters, milliliters, and distance cubed units, such as centimeters cubed, meters cubed, things like that. Does anybody know what we generally measure with volumetric units? Give me an example of something that you could measure with a liter. What is this? Liquids, water. Liquids are measured with volumetric units like mils, liters. Solids are generally measured with centimeters cubed, meters cubed. So you might have a rock, it's really big, and it is a meter cubed, something like that. I might say how many milliliters in 2.9 meters cubed. What's the conversion factor that we know that can get us from a volumetric unit to a distance cubed unit? Centimeters cubed equals a milliliter. Yeah. So if we start with 2.9 meters cubed, so if we write out our unit map, what are we going to have to go through to get to milliliters? Centimeters cubed. And then we're going to get to mils. I'm going to put meters cubed here, centimeters cubed on the top, getting rid of those. Now I'm putting centimeters cubed on the bottom and mils on the top. What can I do? Based on what we just learned, what do I have to do with this? Yes. I can take this 3, the middle step, and bring that out. Can anyone explain to me why I can't bring this 3 out? There's not a 3 on the top. You can only bring out the exponent if it applies to both units. Now let's put in our sig figs, 1 to 1. I mean, sorry, our numbers. And you'll get something along the lines of 2.9 times 10 to the 6 milliliters. Are sig figs correct here? Just a side note. I see you nodding. Why are they correct? Yes. This is metric to metric. This is metric to metric. So we're gonna this is the only thing that's gonna affect our sig figs. Questions, concerns? So this is gonna be on your homework tonight, but we're gonna do a worksheet on this. And actually, one of the questions on the worksheet is on your homework. So I would write down that answer so you don't have to do it again. I think it's the exact number. Because I don't think that one's, sometimes the homework will switch up numbers between students so that you can't all just share answers. But I think tonight that is the exact question. There's one instance, so I said earlier that you always start with an amount followed by conversion factors. There's one instance where you start with a conversion factor, and that's when you're not trying to get from one amount to another. It's when you're just trying to change units, express a conversion factor in different units. For example, if I were going to Canada and I said, and I have a car that's 19 miles per gallon, and I wanted to know what that was in kilometers per liter, I would have to do a conversion factor. The important thing about this is that you have 2 different types of units. What 2 types of units do you have here? What do miles and kilometers measure? Yes, exactly. So miles and kilometers, distance, gallons and liters, volumetric. So you're going to have a distance conversion and you're going to have a volumetric conversion. And we're going to do that by focusing on the top and then on the bottom. So we have 2 conversions that we're going to actually just put into one calculation, but we're going to do 2 different unit maps. The first unit map is we're just going to go from miles to kilometers. That's our number 1. Oh, and let me give you those conversion factors again, if you forgot. The second conversion we're going to do is the bottom units, and that's we're just going to go from gallons to liters. When you do this type of problem, when you're just using a conversion factor and you're changing the units, always write this. I wouldn't write miles per gallon in one line. I would write gallons clearly on the bottom so that you know when you need to cross it out, you're gonna have to put it on the top, right? Because if you have something on the bottom, if you want to cross it out, you have to put that same thing on the top. I would write it as 19 miles per gallon. Write it that way. We're going to ignore this for a second. We're just going to focus on the distance units, and we're going to do miles and kilometers, because what I want is to get rid of miles, and I want kilometers on the top at the end. So 1 kilometer is 0.621 miles. Okay, I've taken care of my distance units. Now I can move on to my volumetric units. Where do I have to put gallons to get rid of it? Top, beautiful. Which means that gallons are going to go on the top and liters are going to go on the bottom, which is exactly what we want at the end. We want to end up with kilometers on the top, liters on the bottom, because it's kilometers per liter, kilometers over liter. Now let's put in our 1 gallon equals 3.785 liters. And we get a number 8.3 kilometers per liter. Questions, concerns? I'm going to give you a problem to practice. It's harder than this one. It's going to take, it's not going to necessarily take this few amount of steps. So write your unit maps, do exactly what we did in terms of going through this. It's also going to involve multidimensional analysis. So you're going to combine the skills we've learned in class today. So your practice question is, what is 2.4 grams per mil expressed in kilograms per meters cubed? Okay, practice that. Raise your hand if you need help. Chris and I are here to assist. I can double check. There's always.
Yeah, that's what I got too. Yeah.
Is this wrong? 19. Yeah, it would be 18.1. Sometimes I put it in my calculator. Yeah, it would be 8.1. So this answer would be 8.1. Yeah, if you ever are wondering whether I got the right answer, just ask me and I'll double check my work, because it's possible for me to make mistakes. 8.1. Okay. Yes, Molly, what I might have done was okay.
This is the most annoying. Oh, that's great. That'd be so cheap.
You go mills all the way to L. L to
Who knows?
Yeah, like. This is a tax bracket, right? So we're leaving on top of it. Way over here, it's still the bottom of it. One tax bracket. Yeah. 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 What's not left. So you got
Okay,
kilograms.
so now I want
That was the first step. So maybe we could go from milliliters to centimeters cubed. Yeah. No, because you already have kilograms at top, right? Kilograms along. So you have to go from milliliters to centimeters cubed. It's the only version that we have. Yeah, you're gonna kilograms along. We don't want to keep them on. There you go. Yes, to cubic. Does that make sense? Yeah, that's perfect. Just write your units.
what? It's gonna be my son. All right, well, that's that.
Because you have it written down right.
100 centimeters.
So always write that down. And then email and what is one that over this. Okay, I'm gonna go over this. Let's just talk about the unit map for the mass units on the top. What's my unit map for the mass units on top?
Grams.
Yeah, grams to kilograms. It's a one step. The top is going to be a one-step conversion. So we are started with grams on the top. We want to end with kilograms on the top. What about for the bottom? Milliliters to centimeters cubed to meters cubed. Yeah. So we're going through, always make sure you write it because these are all units of volume. They always, so the centimeters cubed and meters would have to be cubed. So they have to have that exponent. So you know that 1 mil equals 1 centimeter cubed. We need to use that in order to get to the meters cubed. So that's going to be the what we're going to end up with on the bottom. We want meters cubed on the bottom, kilograms on the top. Let's do 2.4 grams, put mils on the bottom. So we know that we're going to cross it out by putting it on the top in the second step. So we're going to, I'm going to go first, just talk about the mass units, which means what goes on the bottom in the next step. Grams, just figuring on the mass units, and what's going to go on top? Kilograms, because we want kilograms on the top and the end. So 1 kilogram is 1,000 grams. Are we done with mass units? Yeah, we're done with mass units. We figured out the mass units. Now let's talk about the volume units. What goes on the top? Milliliters. What goes on the bottom? Yep, centimeters cubed. And that's just 1 to 1. Beautiful. What goes on the bottom in the next step? Meters cubed. You want meters cubed on the bottom, and you're going to cross out the centimeters. But what do we do with that cube? Pull it out, because whenever there's a cubed to a cube, you're going to pull that out. Why can't you pull the cube out in this? There's no cube on the top. Excellent. What's our conversion factor? 100 to 1. And we're getting a little squished down here, but your answer should be 2,400 or 2.4 times 10 to the third. Centimeter, oh, sorry, that's wrong. What are our units? Kilograms over meters cubed. And you can double check that by saying, well, I got rid of my grams, I got rid of my mils, I got rid of my centimeters cubed. So all I'm left with on the top is kilograms and on the bottom is meters cubed. Questions, concerns?
Just about like the way that I did it. It went faster for me instead of making that lab. Just look at this.
Yeah.
Like I would do one.
That's okay. You just have to make sure that you divide it correctly. Yeah. I don't love to when my students do it that way, but if you do it right, then it's fine. And well, I can talk to you a little more about that during the worksheet. Okay. Let's just do a quick little talk on chapter 3, the beginning of chapter 3. And I'm going to talk about classifying matter by state. Can you all refresh my memory as to the three things that are required of matter. What three things define matter? Not the types of matter, not the types of states of matter. I'm talking about the three things. What's the definition of matter? Talked about it on the first day. Has mass. Takes up space. What's it made of? Atoms. What are the three most common states of matter? Solid, liquid, and gas. We're not going to talk about plasma in this class. That doesn't really apply here. So I do want to talk through these definitions, though. A solid is, we define this by saying it has close packed atoms. They're very close to each other. They have fixed relative positions. That means that they're not gonna, one atom here isn't gonna slide by this atom. It's gonna kind of stay in the relatively same place. Fixed relative positions, and does not fill container. Does that mean that the atoms in this cube are not moving? No. Because anything that has heat at all, anything above 0 Kelvin is moving slightly. That just means that if you have two atoms like this, they're just kind of hanging out next to each other and vibrating. They're just not moving and sliding along next to each other, okay? So in a solid, atoms are still moving, atoms and molecules are still moving. They're just vibrating a little. Liquid also has close packed atoms. They're pretty tightly packed. However, they move relative to one another. Does the liquid fill its container? Yep. Gas has long distances, relatively long distances between atoms. They move relative to each other. And does gas fill its container? Yes. If I release the poisonous gas at the front of the class, I won't do that. But if I release the poisonous gas at the front of the class, I'm not the only one who should be worried. You all in the back should be worried too, because gas fills its container, okay? And then there's a special definition of gas. It's also compressible. As you all know, compressed air is a thing that you can buy to pump your tires. You can use that dust off, which is compressed air, to clean your keyboard. Gas is compressible because there's long distances between atoms, so you can push them closer together. And the relative distance between those atoms is why if you have a little bit of water in a container, when you heat that water up and turn it into gas, it can fill a balloon that's larger than the initial volume of that water, because those atoms are out longer distances between them. Which of these do you think is the lowest energy state? Solid. Out of these three, solid is the lowest energy state. And what do you think is the highest energy state? Gas. this will be important when we talk on Friday about physical and chemical changes and what's exothermic and what's endothermic. And just think about it this way, right? If you and your friend are, you're pretty low energy. I mean, well, you're not moving relative to each other, but you're still sitting there. Your heart is beating. You're breathing. You might be fidgeting. There's movement there. So that's like two atoms in a solid, just kind of sitting next to each other, vibrating. Now, when you start to get up and move around, you're a little higher energy. Then if you started flying around, you would be even higher energy. That's like gas. So you can think of it in terms of like, well, what would take the most energy? Gas is highest energy. And because those atoms and molecules are moving quickly in relation to each other, long distances, solids, you're just hanging out next to each other and vibrating a little. Okay?
I know you said that we're not going to talk about plasma, but like, do those statements like still hold if plasma is part of the conversation?
Yes. So she said, does this still hold as plasma as part of the conversation? The highest energy, I think plasma is still higher energy than plasma. Just is acts more differently than these all do. Plasma is a charged gas, so it's still kind of gas state, but there's but it can conduct electricity. So it's kind of a different class of state. Sorry, I was like, what is the word I'm looking for? So we're not going to talk about that as much. It doesn't come up as much in general chemistry. If you move on to analytical chemistry, things like that, then you'll talk about plasmas. But you all just need to know these three. And plasma is just lightning is plasma. So lightning is electricity going through electrical charge traveling through gaseous air, right? So lightning is plasma. That's all you need to know. Okay, for now. That's all I want to talk about in terms of chapter 3. I said we were dipping our toes in. We will jump feet first in on Friday, but right now we're just going to do a worksheet. I actually gave you a question.